Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.59 from the book Thermodynamics and Engineering Approach by Cengel. Thermodynamics and Engineering Approach by Cengel. So, the statement of the problem is a piston cylinder device initially contained 1.4 kilogram saturated liquid water. So initially in the given data, initially the working fluid is saturated liquid water. Initially saturated liquid water mean that the first state found is on the saturated vapor line, saturated liquid line at 200 degrees centigrade. Initial temperature is 200 degrees centigrade and mass is equal to 1.4 kg. Now heat is transferred to the water until the water volume quadruples and volume become 4 times, mean 4 times. So after heating, V2 becomes 4 times of V1 and the cylinder contains saturated vapor only. Finally, the cylinder contains saturated vapor. It means that finally the liquid is completely dry saturated vapor. So the properties are finally on the saturated vapor line. Find the volume of the cylinder. Number A and required volume of cylinder, and B the final temperature and pressure, P2 and T2, and part C the internal energy change of the water, change of internal energy. So in solution, we start from the state number A, initial state. So this is V1 initial volume and this is P2 T2. So initial, and this is U2 minus U1, del U is equal to U2 minus U1. It means that from the initial state we will find V1 and U1, and from the final state we will find P2, T2 and U2. So initial state, this is initial state. So at this stage the working fluid is saturated liquid. So it means that V1 is equal to Vf and U1 is equal to Uf. So from saturated steam table, at pressure, at temperature, initially temperature is given to us. At temperature T1 is equal to 200 degrees centigrade. Find V1 is equal to Vf and U1 is equal to Uf. At 200 degrees, this is the temperature table and this temperature is 200. So at this temperature the V1 is equal to Vf 0.001156 0.001156 meter cube per kg, and internal energy U1 is equal to Uf This is UF 850.64. These are the initial. So now after heat transfer, volume become 4 times. Now we can find total volume. So total volume, this is specific volume. So total volume, we know that specific volume is equal to total volume divided by mass. Rearrange this equation and find total volume. Mass multiplied by specific volume. Mass is 1.4 kilogram and specific volume is 0.001156 meter cube per kg. So this implies that V1 is equal to 0.0016184 meter cube. This is the answer of first one. Now from state 2, finally at final state the working fluid is saturated vapor. Saturated vapor, it means that these are on the saturated vapor line. So U2 is equal to Ug, V2, P2 is equal to saturation pressure, because from saturated liquid line up to saturated vapor line, pressure and temperature are saturated temperature and saturated pressure. So P2 is equal to PS and T2 is equal to TS. Now we can find this from the saturated steam table. So from and V2 is equal to Vg. V2 is equal to Vg, which is equal to, we can find V2. Let's suppose I am finding here V2. So we know that V2 is equal to 4 times of V1, which is equal to 4 multiplied by, this is in the given data, 0.001684 meter cube. This is total volume. So total volume finally is 0.0064736, 0.0064736 meter cube. This is total volume V2. Now we can find specific volume from this. V2 is equal to total volume divided by mass, which is equal to 0.0064736 meter cube per mass. Mass is 1.4 kg. So V2 is equal to 0.004624 0.004624 0.04624 meter cube per kg. And this is saturated unsaturated vapor line. It means that V2 is equal to Vg is equal to 0.04624 meter cube per kg. So from saturated steam table at V2 is equal to Vg is equal to 0.00464 meter cube per kg. Find temperature, pressure and internal energy. This volume is not available, so we will do interpolation. So V2 is in meter cube per kg. Similarly, P2 is in kilopascal, T2 is in degree centigrade, and U2 is in kilojoule per kg. So let me check this volume and the table. So this volume is 0.004624 0.00 4624. So this is the volume, this is Vg. So at the end of this column, our value of Vg is between these two values. So we will do interpolation between these two values. So this is 0.00495, 0.00495, and other value is 0.00353, and we have to find U2, P2, T2, and U2, and on the volume 0.004624. So this value is between these two values. So now find P2, T2, and U2 in front of these values. So in front of 0.00495, pressure is 21,000 kilopascal and 22,000 kilopascal. Pressure is 21,000 and 22,000, and we have to find P2. Similarly, temperature is 369. This is pressure 369.89 and 373.80. 369.89 and 373.80, and we have to find V2. Similarly, U2 is equal to Ug, and this last column is for U. So these two values for U2: 2230.71, 2230.71. Here we have to find U2, and this is 2081.39. 2081.39. Now first we are doing interpolation for P2 in these values. So third value minus first value, minus first value 0.00495 divided by third value minus second value 0.004624 is equal to 22,000 third value minus first value divided by third value minus P2. So simplify this and find P2. So P2 is equal to, the value of final pressure is equal to 21,229.577 kilopascal. If you want to find this in megapascal, so divide by 1000. Now do interpolation for T2. So for T2, third value minus first value like this: 0.00353 minus 0.00495 divided by third value minus second value 0.0044624 is equal to, for temperature, third value minus first value 373.80, 373.80 minus 369.89 divided by 373.80 minus T2. So solve for this and find the T2, which is equal to 370.78 degrees centigrade. And for U2, third value 0.00353 minus first value 0.00495, third value minus second value. And for U2, 2081 minus 39, 2081.39 minus 2230.70, 2230.70 divided by third value minus second value, which is U2. So U2 is equal to 2196.429 kilojoule per kg. Now to find del U, change in total energy, internal energy, is equal to mass multiplied by change in specific internal energy. So del U is equal to, mass is given 1.4 kg, U2 is 2196.429 minus U1 is U1 is this 850.64. 850.64 unit is kilojoule per kg. Kilogram will be cancelled with kilogram, and this is del U is equal to 1884.1 kilojoule, and this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.